Hello, my dear students. Now we are starting the class 10th English medium physics. Okay, and now I told you the last day that in this period we will study about nature of light. Nature of light. Dear students, now we know the nature of light and the important discussions and views of scientists about the nature of light. What is the views of the scientists about the nature of light? Now I am presenting here views, some discussion of the scientists about the nature of light. So please try and understand what I am saying. Actually, Sir Isaac Newton, Sir Isaac Newton believes that visible light is consist of small particles. It is not I am saying. It is said by Sir Isaac Newton that visible light is composition of extremely small particles, corpuscles of different size, moving with the same speed in the vacuum. It is said by Sir Isaac Newton. What? That visible light consists of extremely small particles, corpuscles of different size, which are moving with same speed in a straight line. All the particles moving with the same speed in a straight line. He said corpuscles these particles. And by his theory, he proved the phenomenon of reflection, refraction, and shadow formation on the basis of the corpuscles theory, corpuscular theory, particle theory. Mr. Sir Isaac Newton proved the phenomenon of reflection, refraction, and shadow formation. By which opinion? That light is the small particles, extremely small particle. Okay. But in the last quarter of 17th century, it was observed that if an opaque object of extremely small size, in the last quarter of the 17th centuries, it was observed that if the opaque object of extremely small size, just like the edge of the razor blade as much extreme, very small opaque object is placed in the path of the light, that extremely small opaque object, if placed in the path of the light has tendency to bend. It was observed That light is moving in a straight line, and any opaque object, very small opaque object, is placed in the path of the light. Light has tendency to bend. Rather than to form the shadow. Actually, when an opaque object is placed in the path of the light, then a shadow formed. But it is not happened here. Either light bends. This is called the diffraction of light. What I am saying? When extremely small opaque object placed in the path of the light bends. It is called diffraction of light. Understood? And after that I want to say to you, if light is particle, then what's happened? Any particle after interaction not bends but fall down. This is a particle. It is moving. After interaction, it will fall down. It will fall down. Let's consider, I want to give an example. Please try to understand. This is opaque. This is opaque object. Okay, and it is extremely small. When light interact with this, light bends. Light bends. Understood? Once again, try to understand what I am saying. Let's consider. This is very narrow, extremely thin. When light interact with this, light bends in all the direction. Okay. If light is particle, then after interaction that will fall down. Not bends, fall down. So there is a question. Is the nature of light is actually particle nature? Because particle after interaction fall down. This is a big question. And after that I want to say to you, there is another discoveries about the light, that phenomenon of polarization, phenomenon of interference, phenomenon of polarization and phenomenon of interference. What is interference? Actually, interference, generally at your standard, interference, this is a light source, this is another light source, both meet to each other, and makes brightness, darkness, brightness, darkness. This is interference. This is called interference. Trying to understand how can it will be possible that two particles after interacting to each other makes darkness. Two particles can interact to each other and produce the arc, light, brightness, but cannot make darkness. But it is possible in the interference. Two light sources makes brightness and darkness that cannot be formed by any particle, any capsular object. So interference and polarization. Polarization is also a happening of light, a property of light. These all affect polarization, interference, diffraction. A particle must be fall down after interact to a opaque object. Must be fall down. But light bends, not fall down, bends in all the direction, not fall down. A particle must be fall down. But here is something other happens. Light bends. That is not possible in the particle. So there is a question mark about the nature of light. That is light particle or not? Because particle cannot bend in every side. Particle cannot make darkness after interacting. Particles have not nature of polarization. So these are all happenings generate a question mark about the nature of the light. And after that, discovery of the interference, polarization. A Dutch physicist, Christian Huygens, suggested that Huygens suggested that light have wave nature. Which nature? Wave nature. Which type wave? Transverse wave. Light has wave nature. Which type wave nature? Transverse wave nature. He suggested to see all this. But at that time, it was not accepted immediately. Because Newton was much famous. He said that light have particle nature, capsular. So Mr. Christian Huygens' theory, conclusion about the light nature not accepted at that time. That light have wave nature, have transverse waves character. It is not accepted. It did not accept it at that time. Okay. And I want to say to you, in 1801, Thomas Young experimentally proved. What proved? That visible light have wave character. Visible light have wave character. And he measured the wavelength. And frequency. He experimentally proved that visible light have wave nature and able to measure the wavelength and frequency. In 1873, Maxwell proposed that visible light have nature or visible light is electromagnetic wave. In 1873, Maxwell proposed that visible light is a type of electromagnetic wave. Visible light is a type of electromagnetic waves. And Hertz confirmed this theory of Maxwell. Mr. Hertz confirmed the theory of Maxwell. Experimentally proved Hertz. In 1887, just after 4 years, Hertz experimentally proved that light is a type of electromagnetic waves. What is electromagnetic waves? What is electromagnetic waves? Actually do not require the medium to propagate. What is electromagnetic waves? The waves which do not require any type of medium, solid, liquid, gas, to propagate. This is electromagnetic waves. But according to capsular theory, yes, medium required to propagate. According to capsular theory, light is composed of particles which travel in the straight line. According to capsular theory, light is composed of a small particle which travels in the straight line at very high speed, which wants medium. According to capsular theory, light wants medium to propagate. But according to Maxwell, light is a type of electromagnetic waves which do not required any type of medium. From these all discussion, it seems that wave nature of light is correct. Wave nature of light is correct. But after some time, also a discovery. What is photoelectric effect? That is explained by Einstein with the help of capsular theory, particle nature of light. Mr. Albert Einstein explained the photoelectric effect, a property of light. Photoelectric effect. What is photoelectric effect? If this is metal plate, when light incidence on this plate, emit the electron. This is metal plate. When light falls on this metallic plate emit the electron. This is called photoelectric effect. And Mr. Albert Einstein explained this happening photoelectric effect to produce the electron on falling the light with the help of the capsular theory, particle nature of the light. In 1905, Mr. Einstein in 1905 explained the photoelectric effect with the help of the corpuscular theory. There is a big problem. Somebody says light have wave nature. Some happenings prove this. Polarization, interference, diffraction. These are all proof that light have wave nature. But photoelectric effect say that light have corpuscular nature, particle nature. Mr. Einstein explained the phenomenon of photoelectric effect on the basis of the particle nature. Sir Isaac Newton explained the reflection, refraction, shadow formation on the basis of the corpuscular theory, particle nature. So there is a great confusion that light have particle nature or wave nature. How can it will be reduced? How can this confusion will be reduced? That light have which type of nature? Particle nature or wave nature? This confusion about the nature of light continued. This confusion about the nature of light continued until discovered the quantum theory of light. This confusion is permanent, continued. When? Until discovery the quantum theory of light. According to the quantum theory of light, light is like a particle as well as the wave. According to the quantum theory of light, it is said that light behaves like the particle as well as wave. Light behaves like the particle as well as wave. That means lights have both nature, particle and waves. Some happenings suggested that light have particle nature as photoelectric effect. Some happenings said that light have wave nature, polarization, interference, diffraction. Sir, when light behaves like particle? When light behaves like particle and when wave. It is depend on the situation. When light behaves like particle, when like wave, it is depend on the situation of interaction of light with matter. This is matter, this is matter, and light interact to this. Light interact to this. This situation of interaction decided the nature of the light. That light is either wave or particle. But it is said on the basis of the quantum theory that light have nature of particles as well as wave. And the particle of light is said quantum particle of light is set what? Quantum, which has a special frequency and wavelength. These quantums, these particle of light have a specific wavelength and frequency. The particle of light that is set quantum, according to the quantum theory, have a specific wavelength and frequency. And these quantum particles moving with the speed of light 3 into 10 to the power 8 meter per second. These quantums, particle of light, corpuscles moving with the speed 3 into 10 to the power 8 meter per second in vacuum. These particles moving, running, traveling in vacuum with the speed 3 into 10 to the power 8 meter per second. Are you understood? Now, I am about to tell you the conclusion of this whole discussion. 1 minute. A narrow band of electromagnetic radiation constitutes the visible light. A narrow band of electromagnetic radiation constitutes the visible light. This visible light, electromagnetic radiation having wavelength 3.9 into 10 to the power minus 7 meter to 7.8 into 10 to the power minus 7 meter. This is the wavelength of this visible light, a type of electromagnetic radiation. Visible light is a type of electromagnetic radiation having wavelength 3.9 into 10 to the power minus 7 meter to 7.8 into 10 to the power minus 7 meter. Actually, this is violet color visible light. And this is red color visible light. This wavelength from this to this contains too many colors of visible light. Particular, not any one color. It's actually and here about VIBGYOR. This total VIBGYOR is visible light. Its wavelength start from 3.9 10 to the power minus 7 meter and till 7.8 into 10 to the power minus 7 meter at rate. Particular nature of light. These all points are remember. me, and you have to remember this. Particular the particle nature of light was given by the Sir Isaac Newton. He explained the reflection and refraction of light by this theory. Albert Einstein used this capsular theory to explain the photoelectric effect. Dutch physicist Christian Huygens put forth the wave theory of light. Who gave first time? Christian Huygens, the wave theory of light. And he explained reflection, refraction, other phenomena, diffraction, interference by this theory. And Mr. Thomas Young confirmed experimentally that light have wave nature. In present time, it is considered that light have dual nature. Light have dual nature, both nature, particle and wave nature. It is depend on the interaction with matter. When light interact with the matter, at that time it is depend that light behaves like matter, particle or waves. First time wave nature suggested by the Christian Huygens, and particle nature Sir Isaac Newton. Too many happenings suggested that light have particle nature. Too many happenings suggested that light have wave nature. But this confusion is continued maintained. So it is said that light have dual nature, particle and wave nature. Now, we know about the common characteristics of light. Now, we know about the common characteristics of light. Let's see here. Common characteristics of light. Common characteristics of light. First common characteristics of light, what is? Light is an invisible energy. That's I told you in last class. Light is an invisible energy which on rebounding from the surface of the matter causes the sensation of sight, vision. Light is an invisible energy. We cannot see the light. When light falls on this board, on rebounding, when light falls, after interaction, light rebounds, enters in eyes, then create the sensation of sight. If light fall on the board and board absorb the light, total light board absorb, then no light rebounds. There is no any light rebounds, then not enters in our eyes. So not create the sensation of sight. Then how can it will be possible that we can see any object? So light is an invisible energy which on rebounding from the surface of the matter enters the eyes and create the sensation of sight. Second nature or character of light. Light travels in a straight line. Light travels in a straight line path. But light is an electromagnetic waves which have transverse in nature. Travels in a straight line. Travels in a straight line. But is an electromagnetic waves. What is the meaning of electromagnetic waves? The meaning of electromagnetic waves means no need of medium to propagate. Lights, no need of any medium to propagate. Lights can travel without any medium because light is electromagnetic in nature. And another thing, what is electromagnetic? Actually, generally, mechanical waves makes crest and trough. Mechanical waves. This is transverse waves in mechanical waves. And compression and rarefaction. Compression, rarefaction in longitudinal wave. There is two types of mechanical waves, transverse waves and longitudinal waves. But light is electromagnetic waves that's forms such type. Electric field and magnetic field. Light form is such type. Electric field and magnetic field. Electromagnetic waves have two fields, contains two fields, electric field and magnetic field. Both are perpendicular to each other. Electric field and magnetic field, both are perpendicular to each other. So light is said electromagnetic waves. When light travels, these electric and magnetic fields takes place to each other. Now this is magnetic field and it is electric field. Next time, this is once again electric field and this is magnetic field. Once again, trying to understand, light is electromagnetic waves having electric property also and magnetic property also. Light is made up with two types of vectors. Electric vectors and magnetic vectors. Both are perpendicular to each other, electric and magnetic. In next term, they interchange to place of one another. This is magnetic, this is electric. Next, this is electric, this is magnetic. Light propagates such type: electric, magnetic, electric, magnetic. This is now electric, this is magnetic. Okay? फिर this is magnetic, this is electric. This is magnetic. Mean to say, in every next term, electric and magnetic vectors interchange their places. Electric, magnetic, magnetic, electric, electric, magnetic. Such type they propagate in a straight line. Okay? The third property, light forms shadow. Light produce shadow when obstructed by opaque object. That means to say, light travels when any opaque object placed in their path, then light makes their shadow. Obstruction, shadow. When light travels and any obstruction in their path, then light makes shadow. Actually, it proves that light moves in a straight line. It proves that light moves in travel in a straight line. Why? If light come here, I am obstruction. After interacting to me, light stopped and there was darkness because light cannot reach there. Once again, try to understand what I am saying. Light forms shadow when any obstruction placed in their path. It proves that light travel in a straight line. If there is no any shadow formed, then means light is not travels in a straight line. How? Try to understand. This is my hand. This is my hand. Light comes on interacting. Light cannot reach here. Then makes shadow. If light after interaction not stopped but move from this side, then reach here, not makes shadow. So formation of shadow. Formation of shadow possible because light stopped after interaction, cannot reach there. Because light does not know the system, the method to turn. Light does not know. Light come here in a straight line. Does not know to turn. Otherwise cannot form shadow. Okay? Now, fourth character of light. What is the next character of light? Listen to me with serious. What I am saying? Light gets reflect back. Light gets reflected back from polished and smooth surface. Light come and reflect back. Light come and reflect back from polished and smooth surface such as mirror, board, still water. Okay? Fifth character. Light gets refracted when it travels from one transparent medium to another transparent medium. Mean to say, light's coming from one transparent medium, it change its original path. It is original path. It is original path of the light, but light change this path when moving from one medium to another medium. Light, when moving from one medium to another medium, light changes its original path. Light not traveling at this path, light change its path. This is called refraction. So light gets refracted, change its path when traveling from one transparent medium to another transparent medium. Change its path, not moving at its original path. The speed of light in vacuum, 3 into 10 to the power 8 meter per second. But in another material medium, in any liquid, in any solid, or in any gas, light's speed is less than to this. Okay. When light travel from one medium to another medium, velocity will be change. When light travels from one medium to another medium, the velocity of light will be change. And also wavelength will be change. When light travels from one medium to another medium, When light travels from one medium to another medium, the velocity will be change due to wavelength. Wavelength also change when light travels from one medium to another medium. V equal to n lambda. N is frequency. Lambda is wavelength. V is velocity. So velocity is changed due to lambda change. But frequency is a special property that never will be changed during reflection and refraction. Once again I told you, once again. Frequency is the fundamental property of the light that's never changed during any phenomenon. Reflection, refraction, interference in any phenomenon. Once again I ask you, which property does not change during reflection, refraction in any phenomenon? Frequency. Frequency does not change in any phenomenon. Okay? Now, your class is over. In next class, we will meet from reflection of light. Good night. Goodbye.